started the list of allocation this afternoon. All the servers are ready, so I could not complete. Okay, I had some issues, couple of hours, so I could not complete the server allocation. So, but I will encourage you guys to watch the video. I think we already have the location. Okay, so you can start watching the video. Make sure you take down your steps. Okay. Yeah. We have limited amount of servers as usual. Okay. And in total, we have about 18 set of 2 servers. 18 set of 2 servers. What do I mean by that? It means that the first server will be like class 1, rack 1. The first set of server, right? Set of 2, class 1, rack 1, and class 1, rack 2. The second set, class 2, rack 1, and class 2, rack 2. The third set, class 3, rack 1, and class 3, rack 2. We go like this all the way till class 18, rack 1, and class 18, rack 2. So it means that this is the two that we use for the rack configuration. So rack 2 node configuration. So first node, second node, first node, second node. Okay, so we just have 18 minus 9 plus 1, 18 minus 1 plus 1. It makes 18 set of 2 servers. So, and that is what is available for both morning and evening. So with this, we always allocated servers based on the group size. Okay. So for a bigger group, we allocate more, we give them more servers. And for a smaller group, they will have less servers. Okay. So RAC goes with 2. That means you guys be configuring RAC 2 nodes only based on this amount of servers available, okay, per group. And the main guideline I want you guys to follow a particular, I want you guys to organize. Let me think again about the type of organization I want. Definitely, I will choose. You guys will make the same organization as the one I suggested in the morning. I want you guys to start this stuff right at the group level. So individually, you will be watching the video, and I know that each person will take down his own steps because that video walks you from the prerequisite OS level changes all the way to the database creation. And I think this afternoon, I also share a document with you guys. Those who started watching the video, they will see that the guy was using this document. Okay, a document like this, similar to this. I share it in the share group, in the common group, common forum. So you guys need this document in order to know what to do. Okay. If you see class 17 rack 1 here, it's because at this time I was student, we were allocated the server class 17 rack 1 and class 17 rack 2. It means that if I give you guys server, if I give you class 1, class 3 rack 1, class 2 rack 2, it simply means that you just have to replace, right? 17 here by 3. Okay, that's the only thing you have to do in this particular scenario. So this is the high level step of what he has been doing in order to configure, in order to run those scripts. And there are some other steps down here on how he configured the grid infrastructure. Okay. So these are the steps for 11G RAC, 11203 RAC configuration. I will show you the slight difference between this 11203 and the 12C RAC configuration. There's no big difference. Okay. So, but what happened is that it's totally fine if you install this 11203 rack. When I will show you the difference between the 11203 and 12C, it makes things very easier for you. Okay. So, what I was actually saying was that I will advise each group to configure rack at the group level. Before that day, before that session, you guys can watch video individually so that individually you have some steps, right? You come as a group, you build, you configure racks together. And I know you'll be more organized because before people watch the video, okay? So you do that, you configure rack at the group level before before configuring rack at the individual level. Let's assume I have, what do you have there? Please mute yourself, right? If you are anywhere, please. It's difficult for us to keep track of those background noises every time. Okay.
Mr. Gata, just mute all, and then the people that are present will probably unmute themselves.
Yeah, okay. All right, no problem. I think now it's good. Everybody's muted except me. So what I was saying is that I would suggest, each group to configure rack at the group level. And once they are done, now they can pass server to individuals. Simply because I will not, these are special servers and you won't have your own server, right? So it means that let's assume there's a group of 10 members and allocate to that entire group of 10 members a set of 3 rack servers. That means 6 servers. It means that let's assume those 10 people have these 6 servers as I highlighted now. It's class 1 rack 1, class 2 rack 2, and class 3 rack 3, and so on. Okay. So they have these 6 servers. It means that if you are to allocate to one person, only 3 people can work because one person we need these 2 in order to configure rack. I'm saying after the group has configured it, now you want to pass it across to every single member of the group. It means that for this set of 3 servers, only 3 people will be able to configure rack. The first person you allocate this set of 2, the second person this set of 2, the third person set of 2. Now, how was I managing when I was in my group in order for everybody to have the chance to configure rack? I know that among the 10 people in the group, I know there are some people who are really willing to configure rack. Okay. So you will start by asking those people, by asking in the group, right? Who is willing to configure rack first? So those people who will volunteer to be the first people to try to start a configuration, you will give them the server. That means the first 3 people, right? And you can give them 24 hours. I was giving 24 hours to people. So I said that if you are really willing to configure rack, we already configure it at a group level. So normally you had very good detailed steps, right? So I give you 24 hours with those servers. Make sure you configure our rack the next 24 hours. And after that, after the next 24 hours, Puff will clean up the server. You are the one to request Puff to clean up the server, not the individual. So that means as a group lead, as the group lead, just tell Puff, clean up these servers. The next 20 minutes, the server will be clean. Okay. So that's how you pass server across. So when you are done, the first person is done, or those first 3 people, right, are done. You can just tell Puff to clean up all those 3 servers at a time. You pass it to the next 3 people, and so on. This is just for the configuration first. After the configuration now, when everyone in the group has configured RAC, now you may need those servers to navigate now. Okay, so at the group level, you can navigate. So I will create a set of small exercises. So you guys now can try to practice those exercises, like backup, recovery, enable archive lock mode, how to play around, create services, enable transparent application failover. I will put some advanced equation like patching or upgrade or convert single instance to RAC. Okay, so that is what some stuff you guys can be using to play around with. There are some activities I will do here with you guys. Okay, if time allows, I will do more, but if not, I may not, right? So especially next week, I'll be available on Monday, but I still have to confirm my availability on Wednesday and Friday. That is something I will confirm Monday. So I cannot tell you now. But on Monday, normally that should be allocated for practicals. So I want to make sure that today or Friday, today and Wednesday, I can cover whatever I can cover on the PowerPoint. Okay, so that next Monday we focus on some technicals. So that's how you guys can be playing around with, those servers. Okay, so please do it at a group level first. Discuss about it. Understand some of those steps. Why do you guys need to watch videos in order to configure RAC? Because there are some steps that you cannot do. Okay, there are some steps that involve a different team, like sysadmin, network admin. That's why the guy put those stuff as a form of script, and you, the GBA, just how to run it. Okay, so but try to understand some of those commands. Try to understand the grid infrastructure configuration. And in case there's anything we can discuss about, just let me know. We talk about it. Okay. Yeah, that's my best recommendation for this configuration. And I hope you guys will have your servers after this session. Is there any question about your servers allocation? What I just talked about? I hope you understood, right? So I shared this document already. So if you are in the merge group, you should have seen this one. It's important because this RAC guide is there, the guide, the book, right? Is used on 11 and 12C. So this is what the guy on the video will be using himself. So this is a very nice book used in real environment. Okay, so short videos, I don't know whether they are working or not, but basically that's how they organize it. And yeah, watch a video and use this document. I don't even know if those videos work. To tell the truth, I don't remember. I really don't remember whether they work or not. Oh, it even work. So we have some short video, like, you see, I don't remember. Some video will work, some video will not work. So please don't rely on these short videos. Okay, don't rely on these short videos. Short videos like this, no. The biggest one will help you to the 3-hour 15-minute video will cover everything. Okay, from the operating system operational the way to the database creation. So you should not worry about these short videos. I don't even know whether all of them work. Okay. So make sure you just have this document open somewhere. It will not help you maybe for this configuration, but make sure you save this document somewhere in your laptop. Okay. And also make sure that you will see this stuff. We talk about the CRS fencing, right? This is what I talked about last session. I talked about the CSS miscount and I talked about the jigs timeout. This is when when we were discussing about node eviction, all right? And I made mention of the CSS miscount. The CSS miscount was the threshold, right? If you guys remember this picture, it was the threshold at which the CSSD process will try to pin the other CSSD process. The threshold is the CSS miscount by default is 30 seconds. So this activity will show you how to increase the parameter to a greater value.
Voilà. Non, je n'ai même pas ça.
Can you mute yourself, please? I don't know. It's Corinne or thank you. So you guys will see from this activity how to increase the CSS miscount. It's very easy, okay? But you should do this after the RAC configuration. And you also learn how to increase the disk timeout, okay? By default, it's 200 seconds. You will learn how to increase it to 600 seconds, okay? So all these are stuff you will do after the RAC configuration. So please watch the video, take down the steps, because those steps are what you will talk about all the way to the interview room. Because in the interview, when they ask you what was your part on the RAC configuration, or the high-level step of what you did as a GBA, you should be able to tell the person or the interviewer in which area you were involved on. So that's why I'm recommending you guys to watch the video individually. If possible, you get to the group, you discuss about it before you configure it. Please, very important. Okay, I think regarding the configuration, I'm good here. Is there any question for me on what we did last class or anything? Can we all turn on our camera, please? I want to know who is here, who is not here. Camera's the problem, bro.
That I'm here, but I cannot turn the camera on one now. I'll go turn maybe later on. But I'm here.
At what time are you going to turn the camera?
When I go get my job here, I'll go turn the camera on.
Okay. No problem.
Yeah, this is Devon. I'm here too, but I'm driving.
Okay. I can confirm, Mr. Devon. So yeah, if you are feeling comfortable like that, it's fine. If not, you can turn off your camera, and once you get home or whatever, you can turn it back on. We can see you driving. So
Thank you.
no problem. Please, what about others?
Like my camera has a problem. I don't know, since I can only connect with the camera using my phone. So.
Okay. Are you able to access your phone at least?
Just that right now I'm at work, but I will get access to it. Let me see, like I'll put it like in let's say in 45 minutes.
Okay. Okay. 45 minutes is fine.
Yes, sir.
What about others? We all know the evening class, it's very difficult for me to keep track of you guys. And so at 6 p.m. there are some people who ask, I will request to turn their camera. Apart from those people giving me some excuses, at 6 p.m. I will request other people to turn on the camera as soon as possible before we can proceed. Okay. Okay. So last session we talk about node eviction. Node eviction, you guys remember, because about node eviction due to missing network heartbeat. And we said that, if one node is not able to talk to other nodes, those other nodes will be able to evict that node, right? And we talk about poison pill, the concept of poison pill, okay? And we also talk about node eviction due to missing Zeke's heartbeat. And that one was the fact that if a node is unable to reach out to at least half of the voting disk, you'll also be evicted, right? From the cluster. Today we are going to continue with IP addresses. Whenever I talk about IP addresses, I talk about connectivity, how connection work from the client side or from the server side. Okay. This is very important for us to understand how connectivity works on RAC. So the exact PowerPoint is this slide. Okay. So on RAC, we have multiple type of network. Okay. We have two main type of network, but multiple type of IP addresses. Okay. So the first type of network is the private network. Okay, what do I mean by private? The private network is the network used only by RAC resources. So it means that that's the network you guys see here, the interconnect. Okay, the interconnect is what allows the private network. So you have private connectivity. Is that network that allows, nodes to communicate and also nodes to communicate with the storage. In RAC 18C, I think, or 19C, I think Oracle separated again those networks. So there's a different private network for the ASM and a different private network for the node. That is something else. But I want you guys to know that the private network is actually what allows the communication, a private communication, right, between the node. For example, if node 1 needs something from node 2, that request will go over the network because they are separated, right? So that network should be strong enough, very powerful, in order for record to be moving around, either across node or from the node to the, or from the storage to the node. So again, the network is dedicated and it is used only by RAC resources. So it means that all those resources, we have a private IP address. It means that each node, we have a private IP address. Node 1, we have a private IP. Node 2, we have a private IP in order for them to communicate, okay? And again, only those nodes are using that network. But now, in order for people to access from outside, we need a second type of network called public network, okay? Public node network. And without a public network, it's very difficult for someone to access a resource from outside, okay? So it means that if you guys are able to access your server today, student 100 or student 367, whatever number you have, is because those servers have public IP addresses. That is what allows you to access a server. For instance, when you guys issue host name, right? Host name -I. When you just issue host name, you will see your student name, right? Don't forget about the domain, but at least you will see something that is similar to your student number. And if you issue -I, you can identify the IP address that is associated to this host name. So some people can connect to a server using an IP address because you don't always have the host name, right? So you can access through PORI using an IP address or using this host name. It will still work, okay? So this is the public IP address. This is actually what allows you to connect from outside. Okay? That's what you guys have been using so far until now, okay? And that is the first thing application team was using to connect to the RAC environment, okay? And I will talk about it now, okay? And if you want to see all the IP addresses and the resolve host name, you have to go to a file called etc/host. All of them should be here. For the RAC, when you guys configure it, you will notice that you have all of them here, okay? You have the local IP, you have the public, you have the virtual. If you want, you can put a scan inside as well. So this is what allows you to connect using the regular poly, okay? Otherwise, you have to take another route in order for you to access the host, okay? So the public internet, okay, is definitely what allows you to connect. Now, let me take an example, okay? This is a little bit how someone is connected to two devices. Just mute the other one, please. Okay, it looks like I'm echoing. That's why I'm, or it's myself. Let me check. No, it's not me. It should not be me, right? It should be one of you guys after connected to two devices.
Everyone is muted, Kaita.
Okay, okay. Now it's good. Thank you, Renata. So I was saying that you guys have been connecting, this way, right? This is how you have been connecting so far. On your children.aura, you will have a host name, right? Maybe you will put here student, whatever, or you will specify the IP address for those who wanted to use the IP address. So this is how the TNS will look like, okay? But now in RAC, because this one is single instance, okay? Single instance, you have only one host. In RAC now, you may have two, right, or more. For us, we have two. It means the first host and the second host, okay? And this one, we have public IP address behind. It means that if you connect to this host and you issue host name -I, you are going to see the IP address behind it, okay? So this is a basic example of TNS name, right? The local one or the global. This one is the service name, okay? For you guys, I know so far, you guys have been using the database name at this level, right? Database name at the service name. But it won't be like that as always, okay? Sometime in the environment, we can keep the same service name, but don't get surprised if there is a different name here than the database name. Let me give you the two scenarios, okay? The scenario when you can see the service name equal database name, or the scenario where you can see the service name different for database name. We may have a third scenario, okay? I will not specify it. So every time you create a database, an Oracle database, there is a service that is created, and by default, they say that the service name is equal to the database name or the SIG, okay? So that's why when you guys put service name equal database name, it works for you because that service already exists by default whenever you create any Oracle database. What is a service? But a service basically, run on an instance, and it's actually what helps people to connect to the database instance. So an example is what? An example is I may not want, some people to have access to my instance directly. And maybe I want them to access my instance through a service. What are the benefits of a service? Assuming that I have 3 people or 3 applications, right, connecting to the same database instance. Application HR, finance application, and maybe e-commerce, right? I have 3 applications. They are connected to the same database or the same instance, okay? Now, if all of them are connecting directly to the database instance, it will be difficult for me to keep track of the amount of resources each of them are consuming. Because all of them are just getting to my instance, right? It will be difficult for me. I have to go very deep troubleshooting steps in order for me to identify the problematic application. In case I'm dealing with performance issues, it's difficult for me to know where the performance is coming from, which application is causing this stuff, okay? Also, it will also be difficult for me to stop one of the applications from running on my instance. So if I have those 3, it's difficult for me to say that I don't want application HR again to run on my database, so on my instance, okay? It'll be difficult because all of them can access directly the database instance. So if I don't want one of the application to run, I just have to stop the entire instance and all the other applications will also be affected. It's difficult for me to keep track of which application, I want to evict. And also, it will be difficult for me as well to allocate resources at the application level. Like I can say that I want to give more priority on this application over this other application. More difficult for me, right, to do that, okay, whenever all of them are accessing the instance directly. So instead, what can I say? In that type of shared instance, right, an instance that is accessed by multiple applications, I can decide that for HR application, right, I will create a service for HR application. That means what? For HR to be able to access my instance, they have to use that service. I will create another service for finance, and I'll create another service for e-commerce, okay? So I can easily keep track of how much resources those services are using. If I just plug the AWR, I will see an area for each service. And also, if I don't want HR to run again, I can just stop that service without having to stop my entire instance. So it's easier for me whenever I'm using services to keep track of every single application connecting to my database or to my instance. So that is how beneficial they are when it comes to a shared environment, right? An environment whereby multiple applications are connecting to the same database instance. But if I have only one application connecting to the database instance, I will not, maybe the services won't be that important, okay? It won't be that critical. Some environment will not use it, some environment will use it, but they are very, very important when it comes to monitoring resources at the instance level, okay? So the service, I will show you how to create it. You can create it even on a single instance or a RAC database, okay? So that's what I'm saying. Don't always expect the service name equal to the database name or the instance name, okay? Don't always expect it, okay? So this is how people were connecting to RAC environment before 11G release 2. This was the only option you had.
Question, Gaetan, please.
Yes, Anita.
Okay, so in the example that you took, whereby multiple departments are connecting, in this case, you have multiple service names, right? In this entry.
Yeah.
Okay.
Yeah, multiple services. One service per application, right? One
Yeah.
service for HR, one service for finance, one service for e-commerce, right? Yes.
Okay. All right.
Yeah.
Thank you.
From the AWR, you can easily identify how much CPU each of those services are using, and you can even allocate resources per service. You can say that I want to give 50% of the CPU to e-commerce, 30% of my CPU to finance, and 20% to this. So you can prioritize resources easily with services, okay? So that is how beneficial they are. Okay.
So is that the only advantage of using a services?
We have multiple other, maybe you have multiple other advantages, okay? But they definitely help to easily monitor an application. That's the whole. Monitor, it helps to monitor an application easily, and it helps you to protect your database instance, okay, from having planned outages, okay? Because by you not having to stop the database instance, and instead, if you don't want an application to connect to the database instance, you can just stop that service instead of you having to stop the entire database instance only because of an application, okay? So you see that it helps to protect your database instance from planned downtime, okay? When it comes to downtime, you can just stop the service and the application user won't be able to connect again to the database instance. And with the service as well, you can enable transparent application failover at the service level so that if an instance is not available, that service can move dynamically from one instance to another instance. But without a service, that will not be possible. Okay. So having a service will help application. It also helps to ensure high availability, definitely. Okay. Because a service being available and you enable application failover, the service will be able to redirect your connection to the next available instance in case if the source instance is down, right? It can redirect the connection to the next available instance. So it has a lot of benefit, definitely.
Mr. Gaita, I have a quick question, please.
Yes, could you?
Could you enlighten me on the difference between a standalone database and a RAC? Or a standalone database, is it the same as single instance?
Yeah, that's what we call single instance.
Oh, well, all right.
That's what we call single instance. Okay.
So why is it being called standalone?
Standalone because only one instance, one database. Okay. Standalone because it's alone, right? One instance connected to one database. Okay.
Okay.
Yeah. Another question? Okay, so I was saying that before 11G release 2, application users have to connect to databases using the public IP address or the host name, right? The issue with this stuff is that when they try to connect, connection will move from one server to another one. So when they are trying to connect, right, they will try to connect to this one first before they can try to connect to the next one. It's sequential. So that means if you have RAC 4 node, they will try the connectivity first on node 1 before it goes to node 2. If node 1 is not available, before it goes to node 3, if node 2 is not available. So it means that in this scenario, one node, the first node, right, we definitely have more connection than other ones because they won't just jump they could not skip this node and just go to the next node. So it has to go to node 1 first. So if node 1 is available, all the connection will always have to go to node 1 first. Okay? Before they can go to node 2. What was the main problem with this? The main problem was that in case this node is down for any reason, or it goes down for any reason, they will have an outage. They will have to wait for at least 10 minutes before they can even receive an error that the node is down or the connection timeout error, and they can now try to reach out to the next node. So in this scenario, 10 minutes, they have to wait before they can test the connection again. They can test the connectivity and being redirected to the next node. And that 10 minutes was called TCP timeout. Okay, TCP timeout of 10 minutes. So can you imagine an application being waiting for 10 minutes before they can even receive an error that there's something wrong before trying to connect? I'm not sure you're a customer, right? Let's assume you were a customer, you cannot accept it, right? So that is the issue we had with the public IP addresses before 11G release 2, because we had only two networks, the private network, and the public network. And on the public network, we had only the public IP address. And this is the main issue we're facing on 11G release, before 11G release 2. Okay, so TCP timeout errors. Okay, they have to wait for those 10 minutes before they can try again to connect, and they will be redirected to the next available node. Because whenever you are trying to connect, right, RAC will try the connectivity to the first node first. If it's not available, then the next one. So it means that, let's assume you were connected to this one. For any reason, it went down or it crashed, right? You wait 10 minutes After 10 minutes, you will receive an error, TCP timeout error, and you will try to connect again. Once you reconnect again, because this node is down, now you will create a session on the next node. So that means at least 11 minutes or 12 minutes for you to be able to connect, right? So that was a big issue. So on 11G release 2, the third type of IP address that came in was called a virtual IP. The virtual IP is the backup of the public IP address. Why do we call it backup of the public IP address? Because it also uses the public network. And now, instead of connecting using the public IP, okay, you can now connect using the virtual IP. So the virtual IP will also be created by the network team, okay, if they are using only the DNS server. They can also create public IP addresses and create the related VIP name, okay? They can create it on the DNS server. So now, those addresses are actually what the application user will be using to connect to the database. So they will no longer use the one you guys know. So it means that when you go to, when you go to configure RAC, you will cut etc/host, you will see another type of IP address after this one called VIP. You guys will see that. Even on Brontech, the configuration, somewhere here, you guys will see VIP configure. You guys will configure the VIP. These are the two. The VIP for node 1, the VIP for node 2. Okay? So the VIP is actually what they'll be using now to connect. Okay? And also, let's remember, each node will have its own private IP for private connectivity, its own public IP, its own virtual IP. So that means if I have two nodes, node 1 will have one private IP, one public IP, one virtual IP. Node 2 will have one private, one public, one virtual, and so on. Those IP addresses are individual. Each node has each of these IP addresses, okay? So that is actually what they'll be using now to connect, okay, to the database instances, okay, those IP addresses. And what are the benefits of the VIP? What is the benefit of the VIP? Again, right, it came to resolve the TCP timeout error we had with the public IP. How? Now, how does it work? Now, if I have node 1 here, and I have node 2, and I have the private IP here, the private IP of node 1, the public IP of node 1, and the virtual IP of node 1. I have the private IP of node 2, the public IP of node 2, and the virtual IP of node 2. Okay, so this private IP, that is the interconnect, right? The interconnect uses the private IP. So this is the interconnect. It's actually what you guys see here, private IP address. Now, these other two are part of the public network. Okay. Now, what's the benefit of the VIP? In case this node goes down, the VIP of this node, let's call it VIP1. Let's call this one VIP2. The VIP of this node will be able to move to the next node. The next node is the one you specify when you are creating a service. It will move to the next node, and while moving, it's going to bring all the connections from this node to this node in order to avoid that wait time of 10 minutes, right? So those connections as well will fail over to the next surviving node you specified while you were creating a service. I'll explain more about how you can specify that node at the service creation. So once this VIP will move, VIP1 will move. Oh, sorry, I put VIP2, okay, guys? It was VIP1, right? So VIP1 will move to node 2. It means that node 2 will have VIP1 and VIP2. VIP1 is there only to service all the connections that were present on node 1. But VIP2 is there to service all the connections that will come to node 2. So the temporal VIP is VIP1 because node 1 is down. So VIP1 is there temporarily to service all those connections. When you bring back node 1, it's functional, VIP1 will move again back to node 1. So VIP1 is here to avoid cost connection to have to wait those 10 minutes, right? Instead, those connections will fail over to the next surviving node. We call that transition transparent application failover. Because it's transparent to the application team, it is happening in the background. Okay? Does it make sense what I just said?
Yes, sir.
Okay. So VIP is actually what enables it. In addition to that, we need a service running for it to happen as well. This is just what is happening. You just see it, right? I'm just explaining that like that theoretically. But behind the scene, there are a lot of setup you have to perform. You have to update your local TNS, and you also have to update server level. You also have to enable transfer application failover on the client side. And you also have to enable transfer application failover on the server side. What do I mean by that? I told you guys that what we enable those connections to easily move from one node to another one will be the database service. It means that at the service creation, when you are creating a database service, you have to specify the failover node. Let's take an example. On the level of VIP, okay? I'm using VIP already. Let's assume I have 3 node rack, VIP, and I will put VIP1, VIP2, VIP3 because I have 3 node rack. Okay? The service name is app_service. For each one, I put HR_service for you to know that this service is for the HR application only. Does it make sense? So now, when I'm creating this service, very important, I have to specify on which node the service should run on. Because I can have a 3 node rack, but the service doesn't run on all of them. If I want a database service, it can run only on one of them or all of them. It's up to me. Okay? So it also depends on the instruction that we give to you while you will be creating a service. So the formula here below, right, is just a basic formula. There are multiple other parameters to involve. This is a basic example of how we create a service. Let's assume I have a scenario like this. This is a new tool you will be using. SRVCTL add service. Please, we'll get there, okay? So this is an example of service creation. You can see here they put service SRVCHL add service minus S, the service name, the preferred node, the available node. This is what I want to explain. Okay. So when you will be creating a service, you are going to specify the preferred node in which you want the service to run on. So you want that service to run on which node? You want it to run on one node or all of the nodes? Let's assume I specify the preferred service, the preferred node is node 1. That means my service will be running on node 1 only. But now, I also specify the available node is node 3. What is the benefit of this? It means that there are some other parameters you put here. I put failover mode, failover type. I don't want to put it now, okay? You can put failover mode, and failover type. There are multiple stuff that I don't want to put this part to do stuff now, okay? So the available node is actually the next node in case this node fails. If that means if node 1 crashes, that service will move to the next available node you specify here. What do I mean by that? It means that if the service was running on node 1 and node 1 fails, those connections will move to node 3. They will not move to node 2 because node 2 is not among the available nodes I specified when I was creating the service. I can put all of them. I can put node 2 here. The service will be running on node 2 and node 3. That means those connections will be shared by node 2 and node 3 in case node 1 goes down. Okay? So it's the same thing. I can also say that the service will be running on multiple nodes at the time. It doesn't mean that the service should be running on one node only. Let's assume I put like this. It means that my database service, I will be HR_ service, will be running on node 1 and node 2. But in case they fail, the service will move and run to node 3. Transparently. That is dynamic. Okay? So that is how important those services are as well. And everything happens at the level of creation. So the VIP allows this thing to happen. Also the service. Okay? And it makes sense what I just explained.
Yeah, it makes sense. So I guess you can say that creating services ensures load balancing. Can you say that?
Load balancing, it can also ensure load balancing, especially when the service is running on multiple nodes at a time, right? That means the load has to be balanced, right, on node 1 and node 2. Okay? So you can do that, but again, right, there are some parameters you need to set. This will not be enough. You will also have to specify these parameters. If you want to enable load balancing at a server level, specify RLB goal. So you see that you have to modify the service and enable load balancing. So the service allows multiple stuff. Transfer application failover, load balancing, security, and multiple other stuff. So if you say that services help for load balancing, you are right. Because you can just modify an existing service in order for you to enable connection load balancing. It means that if the service is running on node 1 and node 2, you can enable load balancing so that the load will be balanced, right, between the 2 nodes. And the service can help you do that. But make sure you put this parameter. Okay? So you can see here, you have two options. Either use the service time or use the throughput. I don't want to get too much in detail on these parameters now, okay? But definitely you can do that with services. Enable load balancing using database services. Since you are not yet comfortable with the SRCTL tool, I don't want to talk too much about the SRCTL tool now until I log into a server and I show you how it works. Okay?
Okay.
Question? So I don't know if you guys understand basically what's happening with this VIP.
Sir, sir,
Yes, go ahead, please.
did you say the VIP act as a backup for the public or for the private?
Public.
For the public.
Mhm.
So how does it help for the public when you have the same IP address? Because
They don't have the same IP address. They have different IP addresses. The network team is going to configure a different, to choose a different IP addresses for the VIP. They will not have the same public IP.
that's more complicating because it's a backup, which means I think how is it a backup when it doesn't have the same stuff as the public?
You just like to say backup, right? Because instead of using public, you can use virtual. That's why we call it backup. It means that instead of you having to use the public IP, you can use a virtual IP. Okay? Don't take it like they should have the same IP. No, they have different domain name and they have different IP addresses. Okay? That is when they are using DNS server. With DNS server, the network team is going to choose different IP addresses for each of those resources. So the listener will have his own IP, the private IP, they will choose it, the public, they will choose it, the virtual, they will choose it, the scan, everything they will choose. For each resource running away on the server, they will choose their individual IP addresses and resolve them on the DNS server. And that makes the job very, very, even more difficult for them, okay? Instead, they can decide to choose another type of server in addition to the DNS server called the grid name server. Instead of DNS, they can use the GNS. I don't want to go into it now, but you have to keep in mind that this virtual IP is different from the public IP. Okay? Different IP addresses, different host name. Just say on what you guys will be configuring, right? Say, you see the public IP plus 17 rack 1. This is the host name, right? When you guys check the public, the IP address will also be different. So the host name is like this for rack 1. For rack 2, it will be like this. But the VIP, the name is plus 17 rack 1 VIP .brontech solution. If I give you plus 1 rack 1 server and you try to change this name while you are configuring rack, it will not work.
Right.
You know why? Because this name is already resolved behind the scene with a unique IP address. That's the name resolution. When they are creating a server, they already have IP addresses. When they resolve a name, that name can connect only to that particular IP address. So it means that if I specify here plus 17 rack 1, okay, and you come and you try to change this name, the rack configuration will not work because this name is not associated with that IP address that they already created on that server. I don't know if it makes sense. It is like I have a scenario like this. I want to take a scenario, right? It is like I am trying to use a server that does not exist. For instance, let's assume I go on Pori and I want to create a new connection. For instance, I don't type the name correctly and I put student 367. I forgot T. For me to be able to access my server, that name I'm specifying here should map the IP address of that server itself. Otherwise, I won't be able to connect. So if I try to open, it will not work. Why? Because the name is not resolved. This name does not exist. There is no server in which this name is mapped to a particular IP address. Okay, so that's why you cannot connect. But if I specify, I write it properly, right? And I put the T behind this name, there's an IP address that exists in Frontech servers. That's why I can connect. Okay, in this particular VPN, right, I'm connecting to. When you guys connect to the VPN, that means you already access Frontech environment. You're in a Frontech network. Now, whenever you are specifying a host name, it will go among the existing server of Frontech, try to identify whether there's an IP address that matches the name you specify here. So if I put this one, it knows that there's a server that was resolved, right, with this particular student 367. And you can now connect and you can see the IP address of that server somewhere. This is something that is done ahead of the time by the network team. If I'm in the network, if I'm in the VPN and I put the wrong one again, let's assume I put 1000, it will go on Frontech in the network and check if among the servers, there is a server with the host name 1000, right? There's something that was resolved with 1000. You will check, there's no server with 1000. There's no matching server with host name 1000 and IP address something, right? So you cannot connect. So that will be the same thing with the virtual IP. So when you guys are configuring RAC, pay attention to the name. If you forget only the hyphen or anything, you will fail the configuration when you are configuring either the virtual IP or the scan. Just try to play around with that, and you will see at the level of the configuration the type of error you are going to have. Okay, so it has different IP, and when you will come to the etc/host, you will see another line below this one. The next line will be there for the virtual IP. We have the IP address and the host name of the virtual IP. Okay, so you will see that as well. So they should have a different IP. I don't know if it makes sense.
Yes, sir.
Question?
So all the IP addresses, both the virtual IP address, the private and the public, they have already been distributed to individual servers.
Yes, they already have it. Yeah, they're already distributed. Okay, so it's already done in the background by the network team. Okay, so you just have to, when you are configuring, just a validation. Make sure that you are using the right host name that will match those particular IP address. That matches those particular addresses.
So Gaetan, please, I have just a question. So the IP address that you have right now, that's the same one that you used to connect to VNC, right?
Yes.
Okay.
Yes.
So
Again, right? Yes.
use the local name or an IP address to connect.
I'm using the IP. I can use the host name or the IP, the same thing, okay? Someone else can use this IP address, right? To connect.
To VNC.
Yes.
Even to VNC. To VNC, because VNC is a tool, there's another metric you have to add on it, a port, right? That's why you guys add another port to connect to VNC.
Yeah,
Let's take an
like
example.
51, 5901.
Okay, correct. So I can connect with student 367 or I can connect with the IP address. So if I use the IP address,
So the IP address, is that individually for you, or like I can also connect with that IP address?
you can connect to this server using this IP address.
Okay, just your server. Okay.
Yeah. So you can connect using the IP address as well. Okay. So if you connect, you guys see that it is still student 367. Okay. So that means student 367 was resolved with this particular IP. So there's a one-on-one relationship between student 367 and this IP address.
And the one that is on top there, the 125, that's the public IP address?
Which one? This is the public IP.
No, I mean like from 19, just on top of the highlighted line to the end of that line. Yeah, that one.
No. What it is? This one is not the. This is the public IP. Let me see what this one is about. This one is different. This is the network IP.
Okay.
Let me see the other one. This is not the one, okay? You should focus on this particular IP address. Okay, so the one you issue hostname -I, sorry, is the one we call public IP. Okay, when you guys will configure the virtual IP, in order for you to see that, you will see another line on the etc/host. There will be another line below this line, because this line is for the public. You guys see this is the public IP, this is the alias, and this is the host name, with the domain name included. Below this line, there will be another one resolved. Below this line, you will see a virtual IP and the virtual domain name. Okay, all of that, you can see that on this /etc/host file. So that's what I'm calling public and virtual IPs.
Please, can you go back to the command to create the services? I wanted to ask you if you have, not that one.
It's a command.
Yeah.
Yes.
So when you go to available, let's say ORCL2 is also not good. Would there be a downtime to transfer to ORCL3?
No.
Okay.
No downtime, because the connection will move simultaneously to ORCL2 and 3. That means if the service was running on node 1, right? Simultaneously, the service will be running on node 2 and 3 at the time.
Okay.
So it means if node 2 is down, that means the service will be running only on node 3. Though there's no downtime. Does it make sense?
Yeah, it does. Thank you.
Okay. Any other question?
Question, Gatan.
Yes.
You issue a host name space -I to see the public address. What about if I want to see the private network address?
It's the local, right? But some people can use IP config. It's IP config maybe.
IP.
Is it space? No. Let me see that. If should be if config, right?
Says if config, yeah. There's
If
no
config,
space. Yeah, it should be if config.
why is it not working? Let me try as root. Okay. So this is, if you pay attention, the public, this is the private. So this is the same thing that you found on this local domain. Okay. So the private is this one, and the public is this one. So just cut /etc/host, right? You identify the private and the public right from the etc/host file. Okay. The if config is just to confirm, because I will not, when it comes to networking part, okay, I'm not expert in networking part, but they have what they call Ethernet, and they have what they call subnets, and they have what they call do stuff. There's a formula they can use using the net mask. Where's the net mask? The net mask, and also the CIGR block. They can use it to calculate the range of IP addresses for a particular resource. I am a bit more comfortable with that when it gets to cloud IP addresses allocations, because in the cloud we talk about subnets, and we talk about
Is it for gateway?
No, don't talk about gateway yet. I don't want to bring us the concept of gateway. Gateway is different, okay? I talk about subnets, we talk about CIGR block, okay? And we talk about net mask. So in order for you, okay, this is the one I'm talking about. In order for you to determine the range of IP addresses to allocate for a particular resource, you need to make a formula between the net mask and the CIGI block, okay, in order to know how many IP addresses to allocate for this particular resource. So that is where I have calculated it before, okay? And the Ethernet are basically how you are accessing the server, basically. So these are just Ethernet, and as a data, I call it Ethernet switch. So it means that when a client is trying to access a server, you access the server through an Ethernet switch, okay? So you go through that port. So if it's ETH0, it means that you are able to access Brontech server because you are going through ETH0. So it means that if this port is no longer available, you won't be able to access it again. You won't be able to access that particular server. And that is something else, because in case sometimes we had some problem with this particular port at work, and that was preventing network connectivity from the client to the server, okay? So those stuff are mainly networking stuff, okay? Ethernet, netmask, addresses, and so on. It's not mandatory for you to master all of them, okay? But at least, right, you should be able to identify the public IP, the private IP, whenever you have access to a RAC server, and also the virtual IP, okay? So when you configure RAC, you will see multiple other Ethernet ports created. I think you guys will also see ETH1, okay? You have more entries than these two, okay? So this is through what you access the server, this Ethernet port. That's why you see a public IP here. ETH0. It has a public IP. So through this particular Ethernet port, you'll be able to access the server. Okay. If you see ETH1, that means maybe you have access to ETH0 and ETH1. Okay. And you can access. So in case ETH1 is not available, you can access ETH0 and so on. So these are just Ethernet ports for connectivity from the client to the server. Okay. So an ifconfig will just tell you the IP address that is attached to that particular Ethernet port. Okay. It's totally fine if you don't understand what it means. Okay. But yeah, that's the basic explanation I can give when it comes to this ETH0 with the related IP address. Okay. Yeah. I don't know if you have any other question when it comes to the virtual IP or the virtual IP, especially. Another question? Any doubt I can help clarify? Just let me know.
Okay, quick question. You said when we configure the service name, we can specify which preferred node or available node, we can have that service name to access to. In case we specify like, we want the service name to connect it to N1, and later on, is it possible to come back and maybe edit and add another node?
Yes, you can modify an existing service. Okay, you can decide that you want to add more node or remove or change the preferred node. Everything you can do that. Okay.
All right.
You can do that. Yes. Okay. Any other question? Okay. So we are going to move to the next concept. Another concept called server pool. Using that concept, I will explain what is scan. So the four type of IP address I will talk about will be scan IP. And that is where I should stop today. Very, very critical and very important. So what is server pool? And why are we using server pool? Let's assume I have 3 applications. Each application has 2 nodes allocated to it. Node 1, node 2. That means what? That application is using 2 nodes to run on, okay? That means its services are running on node 1 and node 2 only. We have sales application. And sales application is using 3 nodes. Node 3, node 4, node 5. That means sales application probably has a service that is running on all those nodes, right? But it's using those 3 nodes. We have another application, maybe up to you, data warehouse or logistic, right? For logistics. So logistics, maybe that this application runs on 2, node 6 and node 7. Okay. Let's assume sales application is the most important. You have to make sure that it's always available, right? Because that is what brings in the money, right? Sales. When you have more sales, definitely the company revenue increases. Okay. So the example here is, if for instance we are on Black Friday we have more sales, but I'm not sure we have more sales than the number of people we hire, right? Or the number of people we fire. Definitely you have more sales on Black Friday that day, right? And the logistics as well may increase, but let's assume that we are on Black Friday, so we have more sales. And for that, the sales application may need more resources, more servers, more CPU, right? Because we'll be dealing with more transactions, we'll be dealing with more connections, more customers, right? So those servers should be ready in order to accept the load, okay? Because the load will be increasing for sure, either online or on site, okay? Now, what happened is that sales application cannot get a node from HR or from logistics simply because they are using dedicated servers. So what happened is that you, the GBA or whoever, may need to come and increase the node yourself, dynamic, add new node to the sales application, okay? Or you may come yourself, manually, you remove this node from logistic and add it to sales. Does it make sense? Or you may need to get another node elsewhere and add it to sales application, just to prepare sales application for the Black Friday, right? Just for as a preparation. And after that, you may need to bring back the node. And there's another day whereby when maybe you have more transaction on logistics than sales, maybe, okay? Maybe other days or other time. In that scenario also, logistics won't be able to get resources from sales just temporarily, okay? So it causes an issue with dedicated servers because you cannot use resources efficiently. Whenever one application needs more resources and the other application is not busy, that application cannot grab these resources from another one. Today, sales is busy. HR is not busy. HR is not using all its resources, right? But sales cannot grab any resource from HR temporarily, right? Just to fulfill the need and give it back later. It cannot work like that because those nodes are dedicated to each application. So that's where comes the concept of server pool, right? Because the server pool now, a node is no longer dedicated to a particular application. A node can move around whenever an application needs it. Okay? And there are 3 parameters we'll be discussing about. 3 parameters. We talk about the minimum number of nodes an application may have, the maximum number of nodes an application may have, and the importance of that application. What do I mean by that? It means that you are going to create what we call pools. You will create a pool for the HR, a pool for the sales, and a pool for the logistics. And HR, you will define the minimum number of nodes HR will have, the maximum number of nodes HR can have. for sales, we define the minimum number of nodes sales should have, the maximum number of nodes it can have, right? And same thing for logistics. What will differ all of them is the importance. How important is HR than finance or HR than sales or logistics? So these are the three parameters we define. So let's assume that I have those three applications. HR, sales, and logistics. And I define three parameters. The first parameter is what? The minimum number of nodes that HR can have is 2. The maximum number of nodes that HR pool can have is 3. And the importance of this application is 10. Please, importance are random numbers. For sales application, the minimum number of nodes it should have is 2. The maximum number of nodes is 3. For these are random numbers. I'm just taking some example, right? And the importance is 40. Logistics, the minimum number of nodes it should have is, let's take 1. The maximum number of nodes it should have is 2. And the importance is 20. What do I mean by this? It means that if there is a node that is trying to join this cluster, that node has to, the most important pool, have to fulfill its minimum number of nodes first before any other application fulfills its minimum number of nodes. Wow. Let's take an example, right? Based on this, sales application is the most important application because the importance is 40. The next important application is logistics, which is 20, right? And the next important application is HR, which is 10. So it means that if I have a new node that is coming to join this entire cluster, that node has to go where first? Where should that node go?
Sales.
It should go to first, should sales first, because sales is the most important application. And it has to fulfill its minimum number of nodes first before any other application. After sales application, which other pool should be the next to fulfill its minimum number of nodes?
Logistics.
Logistics. And after logistics, which one should be the next to fulfill its minimum of nodes? HR. Okay, let's use the same principle for the maximum number of nodes. Which pool should fulfill its maximum number of nodes first?
Sales.
Sales, followed by logistics, then HR. Okay, this activity involves the entire class, and I want you guys us to do it together. Let's assume I have node 1 that is coming. Let me create a pool. This is the first pool. This is one pool, HR pool. This is sales pool, and this is logistic pool. Node 1 is coming in. Where will node 1 go?
Sales.
Node 1 will go to sales. So I have a first node that is joining the cluster. It goes to sales because sales is the most important, and it has to fulfill its minimum number of nodes. Node 2 is coming in. Where will node 2 go?
Logistics.
Sales.
Logistics.
Sales. It will go to sales.
Oh yeah, it will go to sales.
Who believe it go to logistics?
Anita.
No, I changed my mind. It will go to sales.
Okay, I have some justifications, right? Why will it go to sales?
Because it needs a minimum number of 2 nodes.
Okay. Because sales is very important, it has to meet its minimum number of nodes first before the node can go to any other pool. Does it make sense? Make sense to everyone?
Yes.
So it means that node 2 will still come to sales because the minimum number of nodes of cell is 2. Now, let's assume I add node 3. Where will node 3 go?
Logistics.
Because cells already met its minimum number of nodes.
Yes.
Now, the next important application is logistic because the importance is 20, which is greater than 10. So that means any node that is coming will move to the next application. So that means node 3 will come to logistics. Node 4 is coming. Where will node 4 go?
HR.
Why? Why not
logistics? Already met its minimum number of nodes.
So that means that now HR has to meet its minimum number of nodes, right?
Yes.
A pool cannot meet its maximum number of nodes when another pool has not yet met its minimum number of nodes. So all of them should meet their minimum number of nodes first before you can try to meet your maximum number of nodes. Okay? So that's why node 4 will go to HR.
So in the instance whereby the importances are the same, let's say HR and logistics are both 20.
20, the same importance?
Yeah.
That one becomes complicated, right? Why will you put the same importance? That one becomes complicated, right?
Yeah.
Yeah. You may need to divide them a little bit. Make one a bit more important than the other one. Okay?
Okay.
So, yeah. So, assuming node 5 is coming, where will node 5 go?
Yeah.
HR.
Yeah.
HR.
HR.
Why HR?
Because it has to meet its minimum number of nodes.
Node 6 is coming in. Where will node 6 go?
Sales.
Yeah.
Justifications.
Because it has to
because everyone else met its minimum number of nodes.
And then they can meet his maximum number of nodes.
Now they can meet their maximum number of nodes.
No, sir, because I think because sales is more important.
It's more important first, and also because everyone already met its minimum number of nodes, right?
Yeah.
So then it can now meet its maximum number of nodes. Okay? So that means, and node number 6 will come here. What about node number 7? If there's a 7 node that's coming, where will it go?
Logistics.
Logistics. Node number 8.
Can you have that many nodes?
Yes, of course. You get to an environment. Let me take an example. Maybe you think you can even have a cluster of 20 nodes. Cluster environment of 20, 25 nodes. How many cells do you think Google.com has behind? Google.com is used all over the world, right? Google.com has a lot of servers, more than 50. Big super cluster to support a lot of connection. Okay, so it's possible. So if I have node number 8 coming, where will node number 8 go?
To HR.
HR.
So
if I have node number 9, what will happen?
So Can I ask the question?
Yes.
So from here, I think you can now regulate manually where the node should go, right?
What do you mean?
Because if we are following now by the level of importance, I really can't place my point. Like I'm trying to say, like, we can have like 3 nodes on sales, and you can now decide, like, if you want logistic to be, you want to prioritize logistic, you can now probably add the nodes in which you desire.
What do you mean by adding? You go manually, you add a node. Because when you're adding, right, dynamically, this is what will happen.
So you are not in charge of it?
Server pool definitely is what happened. If you want dedicated allocation, you don't use server pool. That's why the first scenario I explained was the manual allocate, the dedicated environment, right? Whereby each application has its own set of server it can use. If it needs more resources, you have to come manually and add more servers or remove servers or increase. Then you have a lot of actions to perform. For this particular environment, if you have to do server pool like this is how it be allocated. So whenever a new server is joining the cluster web, automatically is associated to those respective pools based on the importance. Okay, so that's how it be working. So that's how server pool works. Okay. So that is how it be allocated. Now, let me assume I'm stopping here at 7.7. Let's assume something happened to one of the servers. What will happen?
Before that, you were going to ask a question about node 9. So what will happen?
Okay.
Will it be on standby?
I want to add node 9. Yes, that was my question, right?
Yeah.
Is it possible?
Error.
You can put it on standby, right?
You want it possible, right? Simply because they already made their maximum, all of them. This is the maximum number of nodes. So all of them already made their maximum. So you cannot add any other node.
So where's the, excuse me, where's the maximum? I thought the maximum. Oh, that's true. My bad.
This is minimum, maximum,
right.
Minimum, maximum, minimum, maximum.
I was
These
looking
numbers here are just importances.
I was looking at the importance.
No. Okay, so node 9 cannot be added, right? Until one of the other nodes maybe fell, you want to add it back, right? Then it's possible, but all of them already made their maximum number of nodes. Okay. So now I'm trying to simulate a scenario of a node crash. Let's assume I lost node 1. What do you guys think will happen?
The node to be
nothing.
The node you can go to HR where it's less important than you
request.
You request and pin it to sales, and you map it to sales.
Okay. We're saying something different.
I mean, it already has the minimum number of nodes, so I don't think, at this point, you don't really need to add anything. Unless node 1 and 2 crash, then I guess you can go to HR and request.
So that means you believe that less important application can meet their maximum number of nodes before the most important application?
No.
No.
Sales is more important than any other application, right?
Mm-hmm.
So sales application should meet its maximum number of nodes before any other application. In this particular scenario, HR already met its maximum, logistic already met its maximum, but sales has not yet met its maximum. It's not possible.
Okay.
It has to meet its maximum first before any other node, any other serve, any other application. Does it make sense?
Even though it doesn't need it, it still has to get
It
from.
doesn't need it, but it should meet its maximum number of nodes first.
Okay.
Just based on the importance. So where will set get its node from?
From HR.
HR, it is important.
So you grab one of their nodes, from HR. Another simulation. Let's assume for any reason, I lost these two. What will happen?
And
You get one.
the ZBA need to be fired.
You get from logistics.
You get what?
You just get only one.
You get a note from logistics.
Okay. Okay, she's saying that we will get a node from logistics.
And the other two?
No, just
One or
one.
two?
Just one.
Okay. Who else thinks about something different?
I think you get a note from HR.
So that will not be possible.
Yeah, I think logistics, because the minimum for logistics is one.
Right.
The minimum for HR is two. So logistics can survive with one. HR cannot really survive.
HR is the less important.
Yeah, but HR but HR have not fulfilled minimum level of pool, right? Note. So yeah, I think Anita is right.
I don't think
because logistics already has enough, the minimum.
Right.
HR already has the minimum. So if you take one from logistics, you'll be fine.
Okay. What about the person who said we get it from HR? Any justification?
Yes, I said I should get it from HR because HR is a less important application. It's less than logistics. So if we requires a note from there.
Okay. They understand your point. Understand your point, the logic you're using. Okay, let's go, right? Let's try to understand it. Actually, sales has only one node. HR has two. Logistics has two, right? HR already met its minimum number of nodes. It met its minimum number of nodes, yes or not?
Yes.
What about sales? It met its minimum number of nodes?
Yes.
No.
No.
I'm just taking right before I decided to move anything, right?
Yeah.
Actually, sales has only N4, right? It met its minimum number of nodes?
No.
Okay, what about LG? LG logistic met its minimum number of nodes?
Yeah.
Yeah.
It met its maximum number of nodes as well?
Yes.
Yes.
How come LG can meet its maximum number of nodes when sales has not yet met its minimum number of nodes? Remember what I said, right?
Everybody has
An application, the most important application should meet its minimum number of nodes before the other one also meets their minimum number of nodes. So it means that sales have to meet its minimum number of nodes before any other application.
Wow.
Logistic cannot meet its maximum number of nodes when sales has not yet met even its minimum number of nodes. Simply because sales is the most important. So normally, sales is going to grab a node from logistics in order for it to meet its minimum number of nodes. Make sense or not?
Yeah, makes sense.
So it means N3 is going to move here. Okay. Another scenario. I lost these two.
Wow.
For any reason. What will happen?
You take both from HR.
Yep.
Not both. You take two.
You take both from
Yeah,
it.
that's both now.
No, Anita, I'm seeing my three notes. So if you said both, immediately
There's
said
no
both. I
more
think
three there. There's N5 and N8.
I'm seeing
That's two.
three notes here, right? One in logistic and two in HR.
Yeah, I say from HR. So take both from HR.
N5 and N8.
So Anita is saying that N5
And-
we move here. And it as well we move here. Another suggestion? Any other suggestion? Okay. Can you now explain why you decided to take both from HR, Anita?
Because it is the least important. HR is the least important, and if I take one from HR and take the only one from logistics, that will not be right because logistics is more important than HR.
Okay. Yes, definitely you are correct. You are correct. You are going to get both from HR. Who is not understanding why?
Because what will happen to HR will be evicted.
That means nobody from HR will be able to connect to anything, right? Because there's no node available for HR. So the application will go down. So these are just examples of crashes, okay? So now you can see that all examples are listed, right? Nodes are moving around. Whenever one application needs resources, it can get it from another application, okay? Because it's more important than that application. And that this scenario is possible only with the scenario of server pools, okay? So now that we saw that nodes can be moving across, it's possible, right? Now you have two types of databases when you are creating the pool. So when you are creating the HR pool, it's easy to create a server pool, okay? You just use a CRSCTL command, okay, to create it. When I will get to one of the server, I will show you how to create a server pool as well. It's very important, very easy, okay? So when you create a pool, now you have two types of databases that you can create now on RAC. You can create an administrative managed database. What is an administrative managed database? With that one, you decide on which node you want the database to run on. It means that if I create a database called ORCL and I choose it to be administrative managed, right? I will need to specify on which node I want ORCL to run on. If, for instance, I say that ORCL can run on node 1 and node 2, that means that the database can be accessed only through node 1 and node 2. So with administrative managed databases, you can specify on which node you want the database to run on. When you guys be watching the video on RAC configuration, those databases he's creating are administrative managed databases because you will be checking on which node you want the database to run on. You check the box. If you want the database to run on all the RAC nodes, you will check all the RAC nodes. If you want it to run only on one of the nodes, you check only that node. The instance will be running only on whatever you checked. The next type of database you will have will be called policy managed. And policy managed work with server pool. It means that whenever you create a database now, you can specify on which pool you want it to run. On which pool, on which server pool. What do I mean by that? Let's pay attention to that. That means if I create a database called HR, that database will be running on all the nodes that are found on this HR pool. If a node departs from this pool and goes to another pool, the database will stop running on it. So it will run only on nodes that are part of the pool. If a node moves from one pool to that particular pool, that node will be running that database. That is how policy managed works. So databases are running at the server pool level. I don't know if it makes sense what I just said.
That explain one more time, please.
Can you please explain again the administrative managed database?
The administrative just means that when you guys will call DBCA, right, and you call a database, you have to choose either admin or policy. Whenever you choose administrative managed, they are going to display all the RAC nodes that are available. You just have to check to select which node you want the database to run on. Okay, you select. That's administrative managed. So you have the choice to select where you want the database to run on. But now with policy managed, we don't talk about individual node, we talk about pool. Let's assume I have 3 server pool, right? HR pool, sales pool, and logistic pool. And I want to create the database cells. When I create database cells, I will choose, if I choose policy managed, right? I may need to specify this pool. Okay, let me call it cells_pool, right? Cells_pool. It was already created before, right? So you created sales pool, you created logistic pool already, you created HR pool already. Okay, so when you will select this pool at the database creation level, sales pool, for instance, right? It means that that database will be running only on the nodes that are present on this pool, only on those nodes. It means that if, for instance, right, for any reason, node 1 moves out of this pool and goes to another pool, the database will stop running on node 1. because node 1 is no longer part of the pool, it's out of the pool. Okay? So if another node, like node 7, comes to this pool, node 7 will start running that database. So whatever node is present on that particular pool will be running that database.
Gaetan, please. When you're talking about the HR, sales, and logistics, are you talking about different databases or applications?
Sometimes, right, the application name goes with the database name. Sometimes.
Okay.
Yeah. So if I say HR application, sometimes they may have a database, HR database behind the scene.
Okay.
So, but database name is not always the same. It's not. I'm just taking an example, right? The database name can be different, or it can be the same as the application name. Okay. I'm just taking an example. So it's just for me to easily identify it for you guys, so that it's easier to understand. Because they can call the application can be sales, the database name is different. Okay, can have a different name. I'm just trying to mark them so that you guys easily understand that I will create a database for this HR application, I will create a database for this sales application, and I will create a database for this logistic application. Okay, so the database name doesn't matter.
So in this case, this means all three databases will run under different RAC configurations, right?
They run on different pools, yes, on different pools. For HR, we run on its own pool. Sales database run on its own pool, and logistic database run on its own pool.
Okay.
Any question?
Hey, Gaetan, I got a question.
Yes.
You say if, for example, the node 4 moving to the cell, the database go down. If the database go down, does mean the HR team cannot connect to this database.
No, server or database.
What say?
Server goes down or database goes down.
Server go down, the database go down.
Now, if a server goes down, it doesn't mean database automatically go down. In RAC, it's no longer like that. Because the database can be on RAC. I told you guys that RAC now we have multiple instances, right? With one
Yes, sir.
database. So if one go down, the other one can help, right?
Yes, sir.
You have a complete downtime only if all the nodes went down.
Okay.
But if only one node goes down, the other one can help.
Okay.
I don't know if it makes sense. Just tell me if it makes sense or not.
No, I got you. It makes sense. It makes sense. I was thinking about I was asked one question about the service before, but when you spend one on, it makes sense.
Okay, good.
Okay. Wow. Now you just lost me when you told me about like that the HR, sales, and logistics are different databases. Because I'm just thinking like, is it easy to move from one application to the next, like for the nodes to just move around like that when this HR is one database of it on its own, sales is one other database on its own, and logistics is another database on its own? Like, is it easy to like the movement? I don't know.
Those are different departments. Those are different departments. You have HR department, you have a department for sales, a department for logistics. You, the GBA, just have to identify in which database each of those applications are running on. When they're talking about HR application, which service is it using? And that service, where is it running? On which node is running? It's easier for you to identify it. So I don't understand what you mean by moving around. Connecting to node HR and switching to sales and what? Or what? What do you mean by
No,
moving?
because like when you're talking about single databases, I know the rack configuration is multiple instances to one database, right?
Uh-huh.
And then from what we learned yesterday, I mean last class, I don't see how easy it is to just move from one node to the next.
From one node to the next?
Yeah, like how they just move around.
Say something, right? You're talking about when a node is moving from one pool to another one. You don't know how it's
Yeah.
working? Okay, okay.
So
So
all these, like there are all these databases, all these nodes, they're under one cluster system, right?
yes.
Just one.
Yes.
Okay, that makes more sense. But then when they're different databases, how can they be under one cluster system?
See, this one will be linked to a one database. That means this is a three node rack. A rack 3 node. Okay. First instance, second instance, third instance, all of them connected to one database.
Oh, okay.
This one also is a 3 node rack connected to one database. This is a 2 node rack. 2 instances, one database. It's like this architecture. This is 2. That means you add another one, it makes 3, right? All of them connected to one database only.
Okay, makes sense.
No,
Okay.
but from what you explained is like they're all under one cluster system. So all the nodes are like in connected to one database. That's why I'm kind of confused.
No, it's not like that.
Okay.
It's not like that. So what I'm just see how it looks like, right? This is another way of designing it. Another way of designing it. For the first one, for the second one, for the third one. So you guys see, how do I name it? I name this one node 4, node 5, node 8, right? If you look like this, node 5, node 4, node 5, node 8. The database that is here is for the HR application. HR database, okay? For this one, node 1, node 2, node 6, right? It's another cluster of rack 3 node, node 1, node 2, node 6. This one is for which application? Sales. And the other one was a 2 node, node 3, node 7, right? It's a rack 2 node.
So are they all interconnected?
No, they are different.
Okay, so that means like the ORC of this database will only have information about the HR will only have information about node 4, 5, and 3
and 8.
And 8.
Yes.
So I'm just wondering like how the switch is gonna be easy, just
Exactly.
moving from one.
That's very interesting, because let's assume that you created a database for this HR application. The database will be running only on node, on node 4, node 5, node 8, okay? Same thing, right? If you have a database for sales, the database will be running only on node 1, node 2, node 8, node 6, right? And if I create a database for this application logistics, the database will be running only on node 3, node 7. Now, what you are saying is very, very important. The transition, let's assume that node moving to cells, right? It become like this. Node 8 will move here, and it will stop running on this one, right? Very important question. Now, the database that will be running on node 8 will be sales database now. It will no longer be HR database. Because node, I created a policy managed database, and a policy managed database means that the database runs only on a pool. It's no longer dedicated to a particular node.
Okay.
It means that if I have this pool of nodes for HR, the HR database can run only on nodes that are connected to the HR pool. If the database, if the nodes move out of that pool and go to the other pool, the database that will be running on that pool, on that node now will be the database of that pool. What do I mean by that? On this particular pool for HR application, only the HR database will run on it. On this particular pool, only sales database will run on it. On this particular pool, only the logistics database will run on it. Now that node 8 moved out of this pool and went to the next pool, the HR database will stop running on node 8 because it's no longer part of this pool. Now, which database run on this pool now? Which database run on the next pool?
N8, N1, N2, N6.
Sales.
Which database? Sales database, right?
Oh yeah,
Yes.
sales. Yeah.
Now that node 8 joined this new pool, the sales database will now start running on node 8.
Right.
The transition is what? The transition is that HR database, when node 8 is transitioning, right? That node, that instance will shut down on that node. And once that node moves to the next one, the sales instance will start up on that node. So there will be a shutdown and startup sequence happening behind the scene. Simply because HR database cannot run on this particular pool.
So, sir.
Yes.
So why did you say this on the HR like all of these demonstration are basically one cluster?
Yeah, that's why I'm a little confused.
Yeah,
But like, what do you? So do you have to like? Does it have to be interconnected? Like, do you have to connect it to this sales, this other the node 8? Do you have to connect it since you moved it to sales? Do you have to connect it to all these other nodes?
There's a connection, right? But at this form of pool, don't consider it as connected, otherwise you get more confused.
So, sir, is it the same? Is it the
same connection, okay, between node? Otherwise, if node 8 moves here, how will the interconnect work? We already had a connection before, right? Hey, see, hold on. I told you guys earlier that I can create a database, but I don't want a database to run on all the nodes of a cluster. That was the first thing I said. I said it earlier here. I can have a RAC 4 node, but I decide that my database will be running only on 2 of them. But all the 4 nodes are interconnected, right? But my database can run only on 2 of them. It means that all these guys are interconnected. I don't want to put it on an image, right? So that you guys will get more confused on the cable going around, moving around.
But that's what happens though, right?
That's what happens.
Okay. It makes sense now.
No, sir, it doesn't make sense to me. You've not answered my question, sir.
What's your question? Go ahead.
I'm asking if this demonstration is the same like one cluster or they are three separate cluster.
Now, take it as two different clusters because I said that, let's assume this is a cluster of, how many nodes I have here? 7, 8, 9 nodes. This is a cluster of 9 nodes, right? But my database, I have 3 different databases running on this entire 9 nodes. I have HR database that is running on 3 of the nodes. I have sales that is running on 4 of them. And I have logistics that's running on 2 of them. So I have a big cluster of these nodes interconnected, but the databases are running on different amount of nodes, on different nodes on part of that cluster.
So how come they have different shared storage system?
All of them are in the shared storage, but when you go to the shared storage, right, you will see a folder for HR, a folder for sales, a folder for logistics. It's like when you guys were having single instances, right? You are going to Oradata. You will see a directory for ORCL, a directory for GMO, a directory for whatever you have, right? All of them were under Oradata, right? / Oradata. So that means what? All of them are part of the ASM. But when you get to the ASM, you will see different directory for each database.
Okay, so this little box you sketch here is not the shared storage, right?
This is just a pool.
Okay, it's just a pool.
Yeah.
I'm talking about what the little box that is connected down.
Okay,
that's like a bucket.
You will go to the ASM, right? The ASM gist group, right, is going to take all these 3 together. You will see a folder with sales, a folder with HR, a folder with logistics.
What?
Yes, sir. Now I understand.
Hold on. When you go to Oradata, you see directories there. You have to click on each directory in order to see its data file, right? When you go to /Oradata, cd/Oradata, if you create a database called Anita, another database called Koji, right? On that server, normally under /Oradata, you see still a directory for Anita and a directory for Koji, right? If you cd to Anita, you are going to see system, sysox, control file, redo under the directory called Anita. Same thing for Koji, right? You also see system, sysox, undo, temp, users, and whatever you have here as data file, right? That is file system. So it means that also for the ASM, when you log into the ASM, you are also going to see a directory for each database, even though they are in the shared storage. But in that shared storage, they have their own directories. That is what differentiates them.
Where is this shared storage we're talking about?
Okay, the shared storage, the ASM, is what this thing I'm talking about this.
If you want to sketch, it should be down, right?
The shared storage, that's the one I'm talking about.
Right.
But is that not the database? That's just the database.
No. That is not the database only.
Oh, okay.
Because on a node, I can have multiple databases, right? I can, on a whole, let's assume, let's take an example, okay? I have node 1 and node 2. I have node 1 and node 2. And I go to GBCA and I want to create a database called ORCL. On GBCA, they are going to ask me whether that database should be running on node 1 and node 2 or only on one of them. You are going to select where you want the database to run on. Let's assume you want it to run on node 1 and node 2. It means that one instance will be running here and another instance will be running here as well, because you want the database to run on both nodes. Does it make sense? That is RAC, right? RAC, you decide which node you want database to run on. So that means database you run on both node 1 and node 2. That means if you get to this server, you are going to see an instance called ORCL1. And on the other node, you are going to see an instance called ORCL2. That's the naming convention for administrative manage. So when you do PS minus EF grep PMON, you are going to see ORCL1. If you do PS minus EF grep PMON on node 2, you are going to see ORCL2. The database name is ORCL. If you want to create a second database on DBCA, you call it HR on DBCA. And you want HR to run on node 1 and node 2. It means that on node 1, you will have HR1 for the first instance when you do PS minus EF grep PMON, and HR2 for the second instance when you do PS minus EF grep PMON. You guys can see that on node 1, I have 2 instances running. On node 2, I have 2 instances running, right? At the shared storage level, you have 2 folders. One folder for ORCL and another folder for HR. When you CD to the folder ORCL, you can see the data file of ORCL. When you CD to the folder of HR, you can see all the data files of HR. But all of them are in the same shared storage.
Okay. So my question now is, this scenario will be for the administrative managed database, right? But for the policy managed database, they cannot share nodes, correct?
They cannot share nodes. Okay. What do you mean by they cannot share nodes?
As in, they cannot be, like the nodes cannot be in the same pool. Like the database cannot use the same, both 2 databases cannot use the same node. Right?
Correct.
Okay.
2 applications, yes, cannot use the same node, yes.
Okay.
Yes.
Mr. Gata.
Yes, Mr. Faris.
Excuse me, can you go back where you was before you come here?
What's the question?
My question is, I need to see when I go explain very well.
After you don't understand, right?
The previous, okay, that's no problem. I say, why you say you move the instance, the nodes, you move the nodes 8 to cell database. You said the connect for RAC is like cable. That's mean you have to move the cable.
No. When I'm saying move, right, it doesn't mean that you're coming and moving the server. That is something that's happening in the background. So the instances, when I'm saying moving, right, it means that the instances that are running on that server will shut down and start running on the other server.
Wow.
Taking this example, on this particular node, ORCL1 and HR1 instances are running on this server, right?
Yes, sir.
It means that if, for instance, another application needs this node, all these instances will stop running on this particular node. And the instances of that application will start running on that node now. The example was with this image.
Right, yeah, this one.
Okay. I was saying that I have this node, right? On each node, we have some instances running on each node.
Yes, sir.
So let's assume on this instance, N4, on this node, for instance, node number 4, the instance of HR application was running on this node. That means I have maybe HR1, HR2, and HR3 application running on it. That means the first instance for HR runs here. The second instance for HR runs here because it's a RAC 3 node. So 3 instances are running. And the third instance is running here. So if now this sales application needs one of the nodes here, it totally means that this instance that was running on this node will stop running on it. And now the instance of cells will start running on it now. It's like, I just wanted to use the, some movement, like move node and moving. It doesn't mean that the server is moving. It just means that, let's assume cells had, let me even remove this. I already put node 8 here. Let me erase this to make it clear. So let me also remove this guy because node 8 is already there. I just wanted to be moving a node around so that it makes more sense when it comes to node, but we are not moving the physical servers. So what happened is that let's assume HR1 is running, the instance of HR is running here, HR2 here, HR3 here. Cells, the first instance is running here on this node, the second instance is running here, and the third instance is running here. Same thing for logistic, the first instance is running here, and the second instance is running here. This is a RAC2 node instance, the RAC3 node, the RAC3 node. Now what happened is that, let's assume that node number 4, we start, is going to be used by sales application. This node was running this instance, HR instance, right? Yeah. This instance HR was running on it. So what happened is that this instance will stop running on it. It will go down. And now a new instance from sales will start running on it. That means S4. And this one now, this node now will be linked to the cell application. You no longer communicate with the HR application. So that's why if you want to make it more graphical, it means that only node 5 and node 6 will be connected to the HR database. And now node 4 will now be connected to sales database. The server are not moving. The server are still where they are. But what happened is that on top of that server now, that instance now will start running on it.
Okay. Second question, Mr. Kata, does it mean like the database, they have to create the same server, like the HR, the physical database, like the HR, the cell, the logic, is supposed to be in the same node?
Now, on server pool, when you talk about server pool now, we don't create a database on a particular node. We create a database on a particular pool. So it means that if I create a database and I call a database on sales pool, it means that any node that is part of that pool will run the database. Any node that is part of that pool will run a database. That's why I said that if, for instance, right, this sales application needed one more node, right? It grabbed that node from HR, right? That's an example, because it needed more based on importance, right? It grabbed that node from HR. That is why the instance that was running on HR stopped. And now the instance of the database that is created on this pool will start running on it now.
Okay, Mr. Kata, we know the communication for the instance is the clusterware. Inside the clusterware, we got the Oracle cluster registry. That's what it goes. You go find out this on a physical database. But why does it keep changing? That's one I want. It making me confused about it to do OCR, because if we got 3 database like HR, cell, logic, if it's not the same node, that's mean like we have more than one OCR.
No. The OCR doesn't depend on a particular database. It's not linked to a particular database. The OCR is a cluster-wide level resource. Cluster level resource. Okay? So
Yes.
you can have one cluster where, okay, on a particular node installed, but multiple database instances on that node.
Okay.
That's why I explained last time that the clusterware is not dedicated to a particular database.
Yes.
So the OCR as well is shared. That means what happens is what? The clusterware is installed on every single node here, every single node. Okay? That's why the OCR also is shared by all those nodes. There's one OCR for all of them. We just have multiple databases or multiple applications running on those nodes. That's the only difference. There's no we don't have multiple OCR. We don't need to.
Okay.
You have multiple OCR.
Okay. Thank you. Thank you for explanation. I got it.
So, sir,
Yes, Mr. Kojo.
so does it mean you have basically we have ASM running on every node, like from node 1 to node 7 and to
Correct.
node 8?
That is the default configuration. Yes, ASM runs on every node.
Okay. I'm not
Okay.
I'm not on instance level.
No, ASM doesn't run on instance level. One ASM on a node manages all the instances on that node. I told you guys that the cluster, when you install the grid infrastructure, it comes with the cluster and the ASM, right?
Yes.
Yes,
And
sir.
that means I just talk about one ASM. I never talk about it comes with a clusterware and multiple ASM. No, I said when you install the grid infrastructure, it comes with the clusterware and the ASM. So that ASM is local to that node. So that ASM is actually what we allow all the instances running on that node with the storage. So it means per node, we have one ASM for each node. So for this total, we have 9 ASM. How many? 8 ASM instances, right?
Mm-hmm.
I don't want to bring the concept of flex now, but this is the default type of configuration. We have 8 ASM instances running on these 8 nodes.
But
And all of
one
them,
clusterware.
the clusterware is installed on each of the nodes as well. Because based on this architecture, the grid infrastructure is installed on each node.
Right.
It means that there's one clusterware on node 1, another clusterware on node 2, another clusterware on node 3, and so on. But they are communicating.
Okay.
Okay.
So in this, there will be just one OCR, and it's going to be located in the shared storage.
In the shared storage, the OCR will monitor everything.
Mm-hmm.
Sir, what if let's say for example the ASM is an instance running on node 2 and you shut down the instance of the ASM, what will happen to the database?
If the ASM instance is on node 2 and that ASM instance crashes, all the database instances will also crash on that node. That is the default configuration before the flex configuration. I don't want to talk about the ASM flex now because I'll be contradicting myself when I will get to ASM flex.
Okay.
I told you guys that moving forward with RAC, for you to be able to access the storage, you have to contact the ASM instance first before you go to the storage. It means that every single database instance that is running on a particular node may need to reach out to the ASM instance before it goes to the storage to get any block or to write any block to the disk. So the ASM instance is the mediator. That means what? If that ASM instance goes down, you cannot access the storage. That is the default rack configuration before the Flex ASM comes in. And it makes sense, Sakoji.
Yes, it makes sense. It makes sense.
Excuse me, Gata. That's mean like we here, for example, here we got 8 instances, but for one node we got the CSSD, like the cluster synchronization service demo. That cluster synchronization service demo is running for all of them. It's communicating
111.
1-1. It communicates for all of them who it communicates. Excuse me?
Each node has its own cluster synchronization service daemon.
Exactly. It's communicate for all of them 8 who it communicate by like the pool, like by the pool who it communicate by all of them 8.
For a particular pool, okay, it is focused only on that pool. Okay. So the CSSD, we just, let's assume I have this pool of N4, N5, N6, right? The CSSD, we just make sure that it can communicate with the CSSD of the N5 and N8. That's it. We not care about others because they are not part of the same pool.
Okay. That's mean like one is it go shut down for the connect for moving around, just it goes stop communication for the node.
Definitely yes. If node 4 stop running on this pool and it runs now on this next pool, node 4 start running on this next, we now care about other node now. We no longer care about the previous one.
Okay, thank you.
No problem.
So Gaetan, when it comes to the voting files, like how would that work? Is that just one voting file? I mean,
now I told you guys that even the OCR we don't have one copy, right? I told you guys that for fault tolerance we have duplicate copies in case one is lost. We had the other one, right? It's like the control file. You guys have 2 control files, right? How can you guys justify the reason why we have 2 control files?
in case you lose one.
In case you lose one, you can just duplicate, right? The other, you guys learn how to multiplex control file, right?
Right.
It just helps you to easily recreate the other copy in case one is lost.
Okay.
That's why you also need more copy of the OCR and more copy of the voting disk. It's the same thing multiplexed.
Okay, and all 3 databases will be using just one voting file. I mean, 3 vote or
yes,
one
all of them.
Yeah.
All of them share the same OCR, the same voting files. And databases are not actually what use the OCR or voting files. You guys are trying to confuse something, right? Nodes are actually what uses OCR and voting disk. Node.
So in this case, the nodes will be in the pool, right? It's going to be according to the polls, like the voting disk will be according to the polls.
In general, the clusterware is a node level resource. It's not a database level resource. So the cluster, when you are installing the clusterware, right, you are installing it on a particular node. So it means the OCR will just register whatever information you have on that node. It's true that the OCR will record all the database instances on that node, all the listener, all the scan listener, all the stuff is going to record it. Okay, that's the same, but the voting disk, right? It's just there to record which node is alive, which node is functioning.
Okay, but then when it comes time for like the eviction, it's going to go according to the pool, right?
Eviction?
Yeah, like with the poison pill and whatnot.
Anita, if you
it's at the pool level, of course.
Okay.
At the pool level, that means what? We have to ensure that the communication is happening between node 1, node 2, and node 6.
Okay.
We are not caring about node 1 and node 8. Okay? That means the CS is like what Mr. Fani was asking earlier, right? The CSSD of node 1, how to make sure it can ping the CSSD of node 2 and the CSSD of node 6 and vice versa.
Sir,
Yes.
the little you've explained, I've really understood it. Now you are talking about eviction. You guys are trying to lose me now. For real.
Yeah, let's maybe remove that term of eviction for now, okay? But you guys understand how these server pool stuff are working. Okay?
Okay, sir.
So what is the third type of database?
No, it's just second type. You just have two types. Administrative managed, that's the one you guys will be creating.
Oh,
And
I thought you
policy
said
managed.
3.
No, it's 2.
Okay.
Okay?
Excuse
I sent you guys a video, right, on server pool. You guys can go and watch it on the share group. Someone posted there. Go and watch those YouTube videos. Maybe it can help you to understand a little bit on server pool again. Yes. What is the question?
Miss Marie.
Yes, please, can you a little bit elaborate on the voting this? Why the number should be an odd number and not an even number, please? I don't really understand why.
I talked about it last session, and I said that one of the examples is if, for instance, I had these 3. Let's assume I have 3 node rack. Okay, node 1, node 2, node 3. And one of the nodes leaves the cluster. That means let's assume node 2 was the master node, right? And it leaves the cluster. Only node 1 and node 6 are remaining, right? Now, which one is the master node? One should be the master between node 1 and node 6. Because the node 2, that was the master node, just departed from the cluster, right? So only node 1 and node 6 are remaining. So now there will be a race to become the master node. And the champion, the guy who becomes the master node, will be the node to reach out to the maximum number of voting disks. That is the race. So this example, if for instance I have 3 voting disks, and those 2 nodes now are running, okay, I'm competing, right, to become the master node. Because I have an odd number, it's easier for me to have a champion. Because by the time node 1 reach out to the voting list number 1, node 6 reach out to the voting list number 2, both will be fighting now to go to reach out to the third one. So the first one to get to the third one will become the master node. But if I had even numbers, like 4, we can have equality, and it'll be difficult for us to determine the master. Because node 1 can get to the first one, the first voting list, node 2 get to the second one, node 1 gets to the third one, node 2 goes to the fourth one. We have equality. It will be difficult for me to determine which one is the master. But when I have an odd number, it's easier for us to get the master node. So the first one to reach out to the maximum number of nodes will become the master node. Okay? So this example is just for the race in order to become master node. And it makes sense.
Yes, it makes sense. Thank you.
Unfortunately, I'm not sure I will be able to explain because I had to jump in a meeting at 8:15, and to be able to explain the concept of scan. Now, let me take it, okay? Let me text. I will take 5 minutes, extra minute. Let me just text those people. Okay, so let me just round up with that. I told them I have a 5-minute late, so I will just take this 10 minutes to explain what is scan. So this is the concept of server pool. We have a pool of servers, okay? What was the issue with that? The issue is that on their TNSN.Aura, they may need to specify all the 10 servers on their TNSN.Aura. So, and what makes it difficult is that if one node goes down, you may need to come and remove the node from the pool, from the TNSN.Aura. If you add a new node, you may need to come and add a new entry here on the TNSN.Aura. The example I took, right, was 8. So let's remove this 2. The example I took earlier, right, was 8 nodes, right? 8 nodes from node 1 to node 8. Okay? So it means that I may need to add 8 entries on the TNSN.Aura. Whenever a new node is added to the RAC environment, I may need to come and add a new entry on the local TNS. That means you'll be asking the application team to update their TNS.Aura. Whenever a node is removed from the cluster, you may need to ask. That means if there's a crash, right, like we did a simulation, if a node crashes, you may need to ask them to remove that node from their TNS.Aura file. Okay, so let's assume that node 4 crash. You may need to remove this one, right, because it's down. So you have to tell them, hey, remove node 4, remove that entry from your TNS.Aura because it's no longer available. So every time you add a node or you remove a node from the cluster, they have to update their TNS-name.Aura file. And it gives them a hard time, especially whenever you have multiple people from the application team, right? It's very difficult for multiple people to be doing that. What happened is that instead of having to use multiple, node like that, we decided to use scan, a single client access name. With that, you have only one name that you give to the application team, but behind that name, we have multiple IP addresses. It's like google.com or facebook.com. You guys can just see www.facebook.com, but there's multiple endpoints, multiple IP addresses attached to that, multiple servers behind. Okay? And there's a load balancer somewhere. So the scan now, you will just have to provide one single name to the application team. That means on their TNS.Aura, they will just have to specify the scan name. Only one name. But behind this scan name, we will resolve multiple IP addresses. It is like I have student 367, but behind student 367, we have multiple addresses, multiple servers behind. Okay? So what is the benefit of it? The benefit is that whenever you add or remove a server, they don't have to update their TNS name because only that name is there. It's static. Okay? You don't bother them. And what? This can also help for load balancing. It comes with another component called the scan listener. And how does it work? How does it work? Those IP addresses, right, are resolved on a server called DNS server. It means that on that DNS server, that is where you have all the IP addresses behind that scan name. So as I tried to simulate, right, when I was using PORI, if you are trying to connect, you use the right scan name, the DNS server is going to give you one of those IP addresses. Let's assume I have 3. By default, we have 3 IP addresses. So it means that when the application user is trying to connect using the scan name, right, automatically the DNS server is going to recognize it, right, and pick one of those IP addresses and give to the connection. Now, behind that IP address is attached a unique scan listener. So for each IP address, there's one scan listener. What's the scan listener? Is what last time I called remote listener. What is the benefit of it? The scan listener knows the load on each node. That scan listener now, with the help of the load balancer advisor, it knows the amount of load on each node. It knows how each node is loaded. So when your connection will be sent to the scan listener will now redirect you to the least loaded node. Okay, so that's how it works basically. So you give a scan, the network team, right, create a scan name. Behind that scan name, we have 3 IP addresses. That scan name is what you give to the application user to connect with. They make their 2-tier connection or 3-tier connection. When they connect, they will hit the DNS server. That DNS server will allocate them one of those IP addresses for them to be able to connect, because it recognizes the host name or the domain name, right? So behind that IP address is a unique scan listener. So your connection will be sent to the scan listener, step number 3. Now the scan listener should know among the 4 nodes I have here, which node is the least loaded one, which node is less busy than other one, right? So the scan listener is going to consult an advisor called load balancer advisor. The load balancer advisor knows the allocation on each node, the load average on each node. So the scan listener now, after consulting the load balancer advisor, will know which node is the least loaded one and can now forward your connection to the local listener of that node. You can now go through authentication. The port will be checked, the service name, everything you guys know. Now you can create a connection to that particular node. So now I brought the concept of scan. Single client access name that comes with 3 components: scan name, scan IP, and scan listener. You give the scan name to the application team. That scan name behind the scene is resolved with 3 IP addresses called scan IP in the DNS server. And for each scan IP, there's a unique scan listener. So if the DNS server gives you one IP, attached to that IP is a unique scan listener. And now that scan listener is the one that will redirect you to the local listener or the least loaded connection. That's what we call load balancing. The scan listener helps for load balancing because it doesn't just redirect connection like that randomly. It will check all the nodes and see which node is less loaded, the least loaded node, and forward the connection to that node. That's why we say that scan ensures load balancing. Okay, guys, any questions before I leave?
Gaita, excuse me, did you allocate the servers already?
Not yet. I started this afternoon, I did not finish.
Okay.
Probably tonight I'll be on call, so I will, if I have 1 hour or a few minutes, I will just do that. It's not difficult. I just got interrupted this afternoon with some other activities, so I dropped it. I stopped working on it. I finished with them. There's only one group remaining on the morning class that I had to allocate. I will just finish that. Just 30 minutes enough for me to complete. Okay, guys, please, since it's late, if you have any question for me, keep it for next session. In this load balancing, discuss about it, okay? So I have to drop now. I'm 6-7 minutes late, okay? So thank you for your time again. Let's meet the next session, okay? Thanks.
No, thank you.